certainly can.
Okay, so yesterday you said if you're in here, you have to have the 16.
Yes.
So like that.
Well, let's do a double check. You've got 92, right? 86, 88, 89, 92. Okay, let's go. That's, I mean, it doesn't guarantee that you're going to be right, but at least you've got the right amount accounted for. Okay. No. These are 3D10. Because they're after the 5, S2. And I went through those. You're too far ahead. 4 S2, 3D10. That's where you are.
3D10.
Yeah.
And then 4D6.
Correct. Remember, you didn't make that D1 behind yet. Your D's are 1 behind. So even though you're starting the 4th with the 4 S's, when you get to the D's, they're the 3 D's. When you're in the 5 S's, then you go to the 4 D's. When you're in the 6 S's, you go to the 5 D's. The D's are always 1 behind. F's are 2 behind.
Start off on the 6 go down to X.
Hey, we should bring passes. Which is good because I have
Well, which one are you doing? There is no way you can have a 6 by an S. There is no way that a 2P would ever follow a 3S. There is no way that you would have a 17 by a P. The largest number you will ever have by an S after it is a 2. The largest number you will ever have after a P is 6. The largest... No, we've never done that. When you add up all your numbers at the end, they should total up to however many you had in the original add. But you can never write a S with a number larger than 2 after it. Because it only can hold 2 electrons. There's only one orientation of that one orbital.
You mean conference? Yeah.
Then what would be next after 6S2?
I'm getting 27.
Here's 6S2.
Yeah.
What's next?
I'm hitting 27.
What's next? These or these? I don't know which one you're ending.
I did, but
I don't know which one you're doing.
Yes.
I mean, I did get like one.
Okay, so after your 7 S's, you're gonna do the 6D1,
Well,
and you're gonna go into
oh,
the
I was
5
talking about the
after
varsity. I didn't go
order
to the
the unique.
JV one. Yeah.
These
Oh, but then
These
I
are
also
only
got the
6.
medal.
That's the maximum
That's
by
why
a
she's
P
not
is 6.
competing on Monday because she hit her goal.
But you will never have a 7S and a 6P in the same level. Here's 7 S's. These are 7 Ps.
we don't get that far.
Okay, then the 6 Ps should have been in front of the 7 S's. Because here's the 6 Ps. After it are the 7 S's. Why would you put them before? No, you don't. What you need to do is if you use the noble gas core, you use the noble gas, and then you describe the next level. Just the next level. You really came back for this? Okay. Have a good day.
Well, that was like a $6 drink.
Yeah, but it was also from 7:30 this morning.
That's not that long ago. It's only been 2 hours.
Oh, okay. Which explains the reason I would never have one of those either. Was your first statement? Yeah.
What?
For $15, I can buy a whole container of coffee.
Oh, it's Starbucks.
And water is free for me.
Is it really?
Yep, pull it right out of the ground.
No. That's actually free for me too. I don't pay a dime, a penny. My parents do.
So that would be
I don't
after, so you
I did.
and then just do
Nice.
this. And then you
Do you?
Because we get past this. Technically, the 4Fs finish filling before the 5Ds. So because they finish filling before the 5Ds, we list them
Are
first.
we doing this on the quiz?
Because this one, this very
I don't
one,
think they can.
is 5D1.
Is this thing on the quiz?
But
I don't
because
know.
we're gonna get through all these
I think that
4Fs,
we did yesterday, no.
you list them
So
first, and then
just
this
this
5D1 becomes part of these that you're listing here, and then you have 20 or 60.
Oh, okay. Okay.
So like when we took notes on like the 1, 2, 3, or the
Correct.
4
Then you come back in here,
quantum
what are
numbers, that's
these?
what's gonna be on the test. And then
Which
this
Ds?
with the wavelength, and then
D?
I thought we were doing this.
radio,
It's part of
microwave,
these, yes.
IR.
So we're not doing the all the other things?
Oh,
I think we might
went
want to
10
take
minutes?
B because it's
Okay.
technically quantum numbers.
So that one is kind of a weird one because it's technically before the 4Fs. But if you make it through all the Fs, it gets back in with the Ds when you talk about the Ds, the 5Ds. Okay? Yes. On what?
I've actually no. Like is it like the no? I have no idea.
Would it be like
86, 87, 88, 89, and 4 is 93. Double check that last.
X, you know?
I feel like
Take out your
the
headphones.
first one.
Thank you.
Is the red period?
Yes.
So we're not
This
doing
one
all
is like
these letter
which-
things?
Yeah.
Well, you don't have to. You can,
Okay.
but you don't have to. If you want to use normal gas scores, you can.
Yeah, okay, well, it doesn't matter.
So
I don't know what the order.
Yep. Okay, where are we going to? Well, but where, ultimately, what element are we going to? Okay, so we gotta get to here. So, you did this.
Like if it's here, then
Now
it
do
would
these.
only be that.
Now, to get back into these Ds, we have to get through all of these.
Oh, it's different for each.
So we list those first, yes.
Wait, that makes sense actually.
Because you can only have 2 and 5.
There you go. Okay, and this one here, that's 5D1, gets counted back in here like you just did. Now, if we were to stop down in here, then I would list this one first, because I'm not making it through all of these. But because I'm making it through all of these and back into here, I list them first.
Oh,
Because those completely fill up before the 5Ds completely fill up. Okay? Yes, Rose?
so the EMR is like the color stuff?
Yep.
And then
Wait, Mr. Ram.
the quantum numbers is this
Why didn't you guys?
or no?
No, quantum numbers is the principal quantum number, the subsidiary quantum number, the azimuthal, and the magnetic spin.
Like that's the
Can we,
Is
can
there
we
more
use our paper notes?
What?
You put it on 61.
Just what we've been doing all this time.
Yeah.
So,
okay.
but no, there is no worksheet or anything.
What?
What now?
Can we use our paper notes or is it only?
What paper notes?
Like if we
Like
wrote
if we took paper notes on a notebook.
Why would you take paper notes?
Okay, whatever, answer my question.
Can you use paper? Well, you can, but the quiz isn't on that today. The quiz is not on electron configuration.
Okay, but let's say I took notes
So
on
we're not-
EMR.
So let's say you took notes on EMR and you put it in a notebook instead of on the sheets that I asked you to put it on.
Can I use it?
The sheets that I asked you to put it on?
Dude, you never told us to put all, like, what if we have different types of notes?
What do you mean different types of notes? The only thing that's different is where you chose to put them.
No.
So what you were saying.
Because the notes you told us to write down are not the same as the notes you gave us in the presentation.
And I assumed you would write it down on something you could use since I gave you 2 periodic tables and a yellow sheet that the back was entirely empty.
So, no. Just answer.
So what do you want me to answer?
Can we use them or no?
So what do you want me to answer?
Yes.
Yes.
Yeah.
Yes.
Okay.
Perfect.
Fine. What now?
Jeez, he makes it so hard.
Well, look at it. Okay.
Are you?
Am I what? Crazy, some people say, but none have
Are
proof.
you gonna ask us to write out the number of the element?
No. I won't like to write all 4 quantum numbers out. Okay, so for example, what number represents a d suborbital?
Negative 2.
No, what number represents a d suborbital?
Negative 34.
What do you mean?
A 0 represents an s.
Oh, yeah.
A 1 represents a p. What number represents a d suborbital? 2. Okay? What are the possible values for the p orientations? -1, 0, and 1. Or how many p orientations are there? 3. How many d orientations are there? 5. What is the first quantum number? The principal quantum number. Well, it is the principal quantum number. That's what it is. It can be a 1, it can be a 2, it can be a 3, it can be all the way to a 7. Those are the type of things we're going to talk
I
about.
think it's about this table.
Yes.
So we're skipping the yeah.
Okay, so we're doing the electron configurations like we did yesterday, the 1s2, the 2s2. So you're gonna have to follow along and watch me go over this.
So this one's 0,
Okay.
1,
What?
2, 3, 4.
Okay, but
Yes, you are, because you forgot the 6d1.
And you go back.
That's how much is it?
Oh.
And I'm gonna be
You
confused.
forgot the 6d1.
So that's it?
Yeah, that's the one that you're on.
on.
No, I'm not, because I'm gonna go over and do it right now.
All right, ladies and gentlemen, here we go. Now, again, real quick. People ask me, what kind of questions are you going to ask about quantum numbers? Okay, if the quantum number for the principal quantum number is a 3, how many sublevels are there? 3. What number is representing the s sublevel? 0. S is not a number. Okay? How many orientations are there of a D sublevel? 5. Half of the 10 electrons that fill the D. Those are the type of questions that I will be asking you.
Okay. And then the EMR is like, which one has more energy?
EMR, of these, which one has the most energy? Which one has the least energy? Which one has the highest frequency?
Wait, S is 2, P is 6, D
S
is
is
10.
Those
No,
are
no,
substitute
I'm talking about.
for orientation.
Finish stating what you're asking, because I can't answer the question unless you ask it. Go ahead.
So S is 2, P is 6.
What
D
is
10.
2 about S?
For orientation.
Yeah.
No,
For the sublevels.
no.
That's the amount of
Listen,
electrons.
that's the amount of electrons. And the number of orientations is half of the total number of electrons that will fit. So if there are 2 electrons, it is because there is 1 orientation. If there are 6 electrons, it is because there are 3 orientations. If there are 10d electrons, it is because there are 5 orientations. 2 electrons per orientation. Now you could also say that if there are 5 orientations, there are 10 electrons. Either way. Yes, go ahead.
So let's say there were 6 Fs, so that would mean that there's
Well, but there are not 6 Fs. There are 14 Fs.
14 Fs.
So that means there are 7 orientations. Now, they don't all have to be filled, but there are 7 orientations of the F suborbital that each hold 2 electrons. That doesn't change. Okay? That doesn't change.
What about the 8?
What about the 8? What 8?
Oh, what 8?
Okay, the 8, hang on. Let me put this up here and I will explain a little more. Okay? So, here are your answers, ladies and gentlemen, for this. You're asking a great question, Cynthia, but it's easier for me to show you here. Okay? So this is the electron configuration. To be honest, you don't save a lot using neon as the first electron configuration. You do save a little bit, but you don't save a lot.
this could also be 1s2, 2s2, 2p6, 3s2. Questions?
No.
So we're good with that one.
Yep.
Are we good here? Argon. Okay, 18. Right here. Correct? These are now the 4 S's. So 4s2. These are now the 3d10. Correct? And then these are the 4p5 to get to bromine. Questions? We're good, right? Please say if we're not. Okay, so for osmium, 76 here, we go to the noble gas that's above it, xenon, 54 by it. Okay, again, why put the 18 here so we can go 18, 20, 35? We got all our electrons accounted for.
That's
10, 12, all of them accounted for. 2, 4, 10, 12. Either way, you're going to account for them all. That's the reason we do it. That's your double check at the end. Because again, Mitzi called me over, and I'm not calling out Mitzi, but Mitzi and Lizette called me over and they're like, we're missing for this one electron. And I knew right away where it was because it's an exception. It's one that's easy to miss. But here, osmium. Okay, osmium is right here. So we're going to use xenon, 54. Then these are the 6s2. Okay? Now, this gets tricky because we're ending in here. So what is tricky about it is before I can get to here, I have to go through all of these on the bottom. All of them. And what happens is these 4 F's completely fill before all of the 5 D's. So I list them first because they are completely filled. Questions? This is 5D1. But when I come back up here and I count my 5 D's, 1, 2, 3, 4, 5, 6, I counted this spot, which is actually counting this one. Does that make sense? So that's why we do 4F14, okay? And then finally, 5D6. Questions? Now, this is the one where it's real easy to come up one short. And the reason why is we are ending right here in the 5s. But because we're ending here, we go to radon, the noble gas above it. We do the 7 S's, and then we come down here. Now, I'm not getting all the way through the F's. They're going to be the last thing listed. But there are only 3 F's here. And we have to list this 6D1, or we are going to come up 1 electron short. So 86, 88, 89, and 3 is 92. We have to list this 6D1, otherwise we are going to be 1 short because we are ending somewhere in these F's. Okay? Yes, go ahead.
Don't doesn't 6D fill up after?
Completely yes. But again, we're following a pattern on the periodic table, right? So technically this one, D, for some unbeknownst reason to us, gets 1 electron in it before these do. That's why it's here. Okay? So that's why it's here. So that's why we have to account for it. Now, over here, all of these F's filled up before all of these D's. That's why we list them first. Okay? So again, if we follow along what's on the periodic table, we will just be just fine. Now, back to your question, Cynthia.
Wait. So before, so if we have something that the element is going to end in these bottom ones, we're always going to have to add the 1D.
Yes, otherwise you are going to come up 1 short.
Is it 1D, 1D, or
So remember,
1D?
this is 5D1,
Yeah.
this is 6D1.
Okay, so it depends.
So even if you go all the way to the end here, to F14, you have to list these first because they're before them on the periodic table. So we list these first, and then we list the F's. Now, if we get beyond this, now that we're back in the D's, we will pick this one up when we're counting those. Make sense? Well, I don't know if it makes sense, but that's the way it is. Sorry. I wish the periodic table wasn't like that, but that's the way it is. Now, let's go back to your other question, which is the valence electrons always need to be between what and what? 1 and what? 1 and 8. So here's the thing, and this is what you got to pay attention to, ladies and gentlemen. Okay, let me clear all this crap out. Okay, so if you look here, these are in a lower energy level neon, right? Because they're the end of the row above them. So how many valence electrons are in magnesium? How many valence electrons? How many? No, that's bigger than 8. So look at the third level. How many electrons are in it? So there are 2 valence electrons here. Now let's go to bromine. What is the highest number in front of the S's, P's, and D's? 4. That is the outermost level, right? Okay. So you add up these and these. How many do we get? 2 and 5?
Oh, you're talking about the numbers on top.
Oh yeah, no, I'm
You asked about the numbers
no,
on
I'm
top.
sorry. I didn't even think about what you were adding up. I'm sorry. We're adding up the electrons, which are here, not the energy levels, the electrons. So 2 and 5 is 7 valence electrons. I'm sorry. That's what I didn't understand where you were getting the 8 from, but now I do. Okay. The D's are in what energy level? The third. Is that higher or lower than the fourth? 3 is higher than 4?
Lower.
So because these are lower levels that are filling after the higher S's, they're not part of the valence shell.
So you look at the higher number.
You look at the highest number.
Outside.
Okay.
Or before the letter.
Correct. So what's the highest number before the letters here? Okay, how many valence electrons? 2 valence electrons. What's the highest number here?
7.
How many? That's how we find the valence electrons. So in reality, it helps us that they are behind because then our outer energy level is never more than 8. Never more than 8. This 6 has only 2. Okay? So you'll never have more than 8. You'll never do more, because even if there were P's here, even if these were all filled, they would be back to the 6 P's.
Because S's are the lowest level.
Well, no, not the lowest level. This is the highest energy level being used, the 6th.
Okay.
4 is less than 6. 5 is less than 6. So the highest energy level being used, that's where you'll find your valence electrons. Always.
So it doesn't matter if it's D or F.
Well, no, it doesn't. We're looking at,
The number.
first we're looking at what level they're in, the highest level. Then we do look at S and P's. Valence electrons will only ever be S's and P's. S's and P's will always be a higher number than any D's or any F's that are in your configuration. Always. Always. Okay? So like here, where we have a D and where we have an F, they are going to be lower than the S that started out that level. Always. Okay? Questions? Okay, good. So, ladies and gentlemen, let's go to this. All right.
Wait, and then the orbital is what gets me confused. So is that like
Okay, an orbital
they are?
and an orientation are basically the same thing. So in a sublevel, there are orbitals or orientation. Okay? So remember the P's that went like this, and like this? We could say those are 3 different orbitals or 3 different orientations. Either one. Either one means the same thing.
And it's the way that they're they're spinning?
It's the way that they are. If we were to stop and freeze them, which we could never do, but if we were, we say, okay, there would be some along the X, some along the Y, and some along the Z, so they're as far away from each other as they can get.
So what about the part in the middle? What is that?
The part in the middle is the S, that round part that only has that one orientation. So in the middle is the S, and then outside of it are the P's. Okay? That's why the S's have less energy, because they're technically a little bit closer to the nucleus than the P's.
So then the orientations are the way it's like moving either.
Not moving, but the way if we were to stop it, the way we would look at it in space. Meaning along the X, the Y, and the Z. Then the D's are in between X's and Y's, X's and Z's. They're not perfectly in X, Y, or Z because there's already the P's there, so they're kind of in between them. Okay? They're kind of in between them. Good. I'm glad this is making a little more sense as we go through it.
So the sub-levels is the same.
The sub-levels say, what are there? Are there S's? Are there S's and P's? Are there S's, P's, and D's? Are there S's, P's, D's, and F's? There are no F's in the first three levels. Okay, the F's don't appear till the fourth. Okay, now, again, they don't fill until later on, but they do appear in the fourth energy level.
And that's why it's like 0, 0, 1, 0, 1, 2.
Correct. That's those numbers. All the quantum numbers is a way of mathematically figuring out how many spaces there can be for electrons. Okay? That's what it is. Okay? Questions? Okay. Somebody please give me the electron configuration for nickel. You can use the noble gas core if you would like. AR18. Okay, go. 4s2.
And then 3D. No, 8.
Okay. So now the K, the L, the M, the N, the O, the P, the Q represent how many electrons are in each of these levels. And they're just 1 through 7. They use letters instead. So when you use a noble gas core and you have this 18, it's hard to figure out where those 18 are. So next to argon on your periodic table, ladies and gentlemen, I have listed the electrons and the way they are arranged around the nucleus. So by argon, they are 2, 8, and 8. Okay? So that's where I get these numbers from, 2, 8, and 8. That accounts for the 18 around argon. Now I need to go and say, okay, in the fourth level, there are how many? So I go to the fourth level and I add 2. Now in the third level, these are already accounted for in argon, but now there are more in the third level. How many more? So now I have to take this 8 and add these 8 to get a total of 16.
So it also happened like when we did the bromine, when we had the 4s2 and the 4p5, we still have to add those up.
Well, remember, if you're using the noble gas above it, you're only adding in what is after that. And the only time you have to go back and add something is if there happen to be S's or D's or F's that are filling later on. Because they weren't accounted for in here, but they are over here. Does that kind of make sense or not really?
But like for like the bromine, we had the argon 18, and there was the 4s2, 3d10, and the 4p5. Would for the fourth one, would it still be 7, or would it only be one of them?
It would be both P's. It would be both fourth, the S's and the P's.
Okay.
You would add them together. All right, so let's do beryllium, and we're not going to do a noble gas core because beryllium is the second element there. What is it? 1s2. I have no idea why I just wrote 1, 2, 2. 1s2, 2s2. So how many in the K?
2.
How many in the L?
2.
That's it, you're done.
Oh.
Okay, let's do sulfur. Let's do sulfur with neon. All right, now describe the last level to me where sulfur is. 3s2. Keep going. 3p4. Right? I think I'm going to lose everything, but. Okay. So neon, 3s2, 3p4. Right? Okay. Let's see if I lost everything. I think I did. Yep. Okay. So again, this was neon 10, 3s2, 3p4, correct? So neon 2 and 8. And now the third period has how many more? Try again. 6.
Oh,
The 2 here and the 4 here, because they're both in the third, we add them together and put them to this number. That's our 16 electrons.
Is this thing gonna be on the quiz or no?
On today's quiz?
Yeah.
Heck no. But this is a good clue for a test. The element named after the principal of East High School has a K value of 2, an L value of 8, and an M value of 6.
You have nickel and beryllium on there twice.
Wait,
I don't even know.
for number Ni, so you have A is
For Ni, we did, I'm sorry, it went away, argon, 18. And then we had 4s2, 3d8. Now this 18 gives me 2, 8, and 8. That's the way argon is because of the numbers after it. Okay? If you look above your head, they're on that table too. Right next to the noble gases are the configurations.
That's
Okay?
crazy.
So now,
Wait, why is
This-
it 9?
what?
For the like
There's no line on there.
no, look, okay, you know the 2 bottom rows that are like out of it?
Oh.
It goes 2, 8, 18, 32, 9, 2. That says 9 twice. Unless they messed it up and they meant to put 8.
No, it does,
There-
yeah. It also says 32. I didn't think you would have 32.
Yeah, you can. Because the RN has 32.
It's special. They're special.
No, remember, that is the D1.
Oh.
Remember, there is one D1 in there
Yeah.
that is one behind. So that is adding to the 8 that are in the S's in the 6th. I'm sorry, that would be the 5th.
Yeah.
And there is one 5D1. There is supposed to be that 9 there.
Oh, okay.
Like uranium, you remember how we had that one 5D1? Well, if you go back and add that 1, there were 8 before, that makes it 9.
Okay.
Okay, so that is supposed to be a 9.
Gosh, so
I've never noticed that those were there before, thank you. I knew they were on the end, I didn't know they were after those.
wait, so 288 at the end, does that represent the number for all the ones in that?
In that argon. In argon, the 288 represents the noble gas.
So these numbers are only representing the normal gas.
Correct. Now we need to add the rest of what we wrote. And we wrote in the 4th that there are 2. So I put 2 in the 4th, in the end. And now there are 8 more in the 3rd level, which is the M. So I have to erase that 8 and now make it a 16. Now, the one thing that I will tell you is that the last number in all of these will always be between what?
1 and 7.
1 and
6,
8.
8. Why 8?
Because that's the maximum number of valence electrons when you think of a full S holding 2 and a full P holding 6.
But then, like, why did you make up a 16?
There are 2 here
Yeah.
and 6 here. That's 8. There are 2 here and there are 6 here. That's 8.
But then how?
There are 2 here, there are 6 here, and these are 1 level lower.
Oh, okay, yeah.
So that's where we get the 8 from always. We never go over the 8, because even here, these are 5th period S's, 4th period D's, and then back to 5th period P's.
Okay.
So those will always be somewhere between 1 and 8. Questions?
Okay, I got it now.
Why did we change that to a 16?
Because this 8 here adds with the 8 that was in the 288. 288, the third level has 8 for argon. Here's more in the third level. So we have to add them together. Okay? So we add the 8 that were in here and the 8 in here, and we get 16. Okay? So let's do chromium, because that one will do the same thing. For chromium, we're going to use argon. Argon is 18. For chromium, you have 4s2. And then 3d4. So this argon here, Kp, 288. Well, here's the thing. I don't know if I'm going to be adding or not yet.
But you are.
Okay. If you want to do it differently, you are welcome to. But I start by writing out this noble gas core because, believe me, we'll do uranium in a second. It gets a little bit more confusing. Even though it's not hard, it just gets a little bit more confusing. So now I'm adding 2 to the 4th, and now I'm going back and adding 4 more to that for a total of 12. Again, last number, never bigger than 2. Or never bigger than 8. Okay? Let's do uranium. For uranium, that is radon. 86. Okay? Then you've got 7s2, 5d1, 6. My bad. 7s2, 6d1, 5f3. Right?
You're already on the wrong one.
Sorry.
Why'd you just get up and erase it?
Because the eraser is so damn big that it...
I'm talking about the board. You have
Yeah, you still have writing on the board.
So, it was like
Well, then, sorry. I'm multimedia and I'm old school at the same time. Okay, so now, for the 86, next to radon, we have 2, 8, 18, 32,
Oh my god.
32, nope, I'm sorry, 18, 18, 8. So now I need to go into the 7th level and add how many? 2. I need to go back in the 6th level and add how many? 1. So this 8 becomes a 9. And I need to go back into the 5th level and add how many? Now, if you can do all that in your head, go for it. Go for it. I do it one step at a time. I write down what the noble gas gives me, and then I go back and add what is in here afterwards. Okay? Questions? Okay, good.
21.
Huh?
18 plus 3.
Sure, go ahead. 18 plus 3, yes.
What is this called? Like what we're doing?
All this is basically, instead of, there are different ways to look at electrons. You can break it down into sublevels. That's what these are, the S, the P, that's everything. It's broken down as you can be. Sometimes people only care about how many electrons are in an energy level. That's what the K, L, M, N, O, P, Q are. I don't care where they're at. I just want to know how many are in a level. And by the way, if you add up these numbers, 2, 8, 10, 22, 24, that should be the element chromium on the periodic table.
24.
Yes. So remember, to start out, the number of electrons and protons is
Even.
equal. Equal. Questions? Okay. Now, do you remember what was weird about the transition metals?
They're one.
That they can do what?
They can be any charge.
They can be multiple charges. Let's explain why real quick. Here's why. It's called the degenerate orbital, ladies and gentlemen.
We have to know that,
Not for today's quiz.
but in general, like, should I write it?
It'll explain things that we see later on.
Like we
This is
have-
in your notes.
I
Don't
have
worry about it.
screenshot notes for the test.
It's in your notes. Copper can be a +1. Here's how we explain copper being a +1. If there is only one electron in the 4s, it loses that electron and it would act like a +1. The problem is there should be 2 electrons here, right?
Yeah.
Where'd the other one go?
The
Well,
three.
instead, it went to a 3D. Why? Not a lot of energy difference between a 4s and a 3D.
That's true.
So instead of being here and repelling each other, it says, all right, you know what? I'm going to go over here. Now, again, this isn't what we want to happen, but it is the only way we can explain how copper could act as a +1. Is if this electron moves over here and then we lose this one. Fair enough? How would we explain it's a +2? Well, the 2 that are here, both go away. No degenerate orbital. Which means, loses these 2, it's going to have a +2 charge.
Oh.
It explains why these things happen. Okay? That's all it does, is explain why they happen. Okay? And later on, we're going to see that carbon, the element that is the basis of life on this planet, definitely has a degenerate orbital.
Carbon?
Carbon.
But
Definitely
it can only be
has
one
a
charge?
degenerate.
Oh yeah. Wait, it can only be one charge though.
Correct. But carbon very rarely acts as an ion. It normally shares electrons instead.
Yes.
And we will explain how carbon can share 4 electrons instead of only 3. We'll get to that. Okay? Or instead of actually only 2. All right, questions?
Wait, I'm so confused on this.
Why is it confusing you?
Like, how do
I'm not expecting you to tell me when this happens. I'm not expecting you to even understand much of it. This just explains how copper could act as a +1. The only way it could act as a +1 is if there's only one electron here, and it loses it. The only way there can only be one electron is if the second one that was supposed to be here moves over to here.
Okay, but why would you move it? Like, why
We
would-
don't.
why-
We don't.
We don't. Carbon or copper just does it. Some copper atoms just do this. And then when they combine with something else, they act like a +1. Some don't do it. And they act like a +2. Questions? Put your computers away. Put your phones away too.
Sorry, Bresky.
Excuse me?
I said sorry, Bresky.
Did you forget my name?
Now I know your name.
Grand. Who names their kid Grand?
Where's your last
Well,
name?
you know, you realize that last names were different than first, right?
Well, yeah.
Okay.
Where's your last name from?
My mom and dad.
No, but like, never mind. You suck.
Hey, I already told you.
I believe it has to do with the fact that Brain is of German heritage.
Oh, okay.
Or
That's what I
because-
wanted to know. Thanks.
Actually,
I wrote all this stuff on here for a reason.
Raisin
Why? You
bran.
said I didn't need all this stuff.
Do you know what
Literally
her
what
last
the whole
name
thing's
means?
about, buddy.
It means one who likes to mix with cereal in the morning.
Why don't I get one? Why?
Can you
did
wait
get a
for
different
your
version?
turn?
My last name means. Why do I have so many names?
Why is it so many pages?
Because some of the questions are long.
Boy.
Why does my
Oh,
last name
thanks.
have this?
Multiple choice?
Yeah.
Wait,
It looks like
Why are you taking 2?
You gave me
Okay, which one do you want? The easier one or the harder one?
the one that's not so easy.
Wait, why do I get to choose A? Why does she get a better grade than me?
She's the easier one? Is that what you said? Can I have the easier one? Can I have the easier one too?
Mr. Brand just
You want to trade?
You're giving me a better grade than you grading the test. That's crazy.
Better take the answers off the board before you find the questions that go with it.